Good afternoon, everybody. I am going to go over the general linear model, looking specifically at ANOVA and regression, and we are using that to study depression in children and the likelihood of depression in children specifically. And we're using it through three different factors. We're looking at it through covariates. We're looking at home stability, self-reported happiness of the child, and group support groups availability. And we're using these as the descriptives. There's the means, standard deviations, and the number of participants. And then our null hypothesis is that there is no significant difference between a child's likelihood of depression and the following factors: home stability, self-reported happiness, and support group availability. Now we're first going straight into our first of the two models, which is ANOVA. We're going to use a type 2 sums of squares. We do an analysis of variance, so we're ANOVA. Basically, ANOVA analyzes the variances between groups versus the variances within the groups. They call it the signal over noise, or like the signal over the error. So in group variances. So look at the model. We have the sums of squares of the variability about the mean, which is 16.283. Look, that's on the type 2 sum of squares column. You look over far right, there's a significance column, and it gives a significance of 0.564. And since that is greater than 0.05, which is our limit, the overall null we fail to reject because it is greater than that. So we kind of start looking at why. So we look at the R squared, or variance from the other factors that on the model, and that is 0.282, which essentially means that 28% of the variance comes from home stability or self-reported happiness. Now we look at the significance for the rest of the module. On the right side, significance, and there's no other significant differences below 0.05. Now we got to start looking at this like, so why is the variability so high? So we start looking, it's like, well, maybe it's homoscedasticity or homogeneity variances. Essentially, it's like, are the variances roughly the same? Are they similar? And so we check that. We use this F statistic. We try to find the maximum amount of variance we can have, limit. And we look at the largest one here of the different factors, which is home stability. And we check over the F statistic. It's 2.509. And how I check that is we take the degrees of freedom, which is of the home stability, which is 2, stability column 2, and do it by the total number of degrees of freedom, the df of total, which is 30. And we go to an off-screen table, of F table, and we get the F max of 2.487. Now, 2.509 is greater than 2.4887, means that we fail the assumption from homoscedasticity, means it's heteroscedastic, and the variances are not similar. All the other variances are good. I've already checked those off screen. Now, moving on to the next assumption is that the dependent variable, or depression likelihood, the data is measured for that in either interval or ratio. And you can see at the table top right, the depression likelihood is highlighted in yellow, and the measure itself is a scale, which is interval or ratio data. That's what it says. So the independent variable, or the IVs, for the next assumption is 2 or more independent groups. And if you look on the right side under IVs, you have home stability, which is 3 groups, and self-reported happiness is 5 groups. Finally, the third one for this slide is independence of observations, assuming that all the participants were randomly assigned. And since we were given this data by Patrick, our professor, we say it's like, well, it must be a good assumption. Right, Patrick? Moving on, we're looking at the non-significant outliers. All right, so we look on this curve, which we talk about in a minute. And basically, we have a small grouping around -2 on this curve, but since it's still on the curve, it's not farther out. That's definitely a good sign, so it's not significant. Now, degrees of freedom are approximately normally the dependent variable is approximately normally distributed. And since we have that, that's what that black curvy line, our bell curve, means, is that there is a bell curve, there is a normal distribution, so we can yes, it's good. That assumption. Now we're going to move on to another module, the general module called the regression. Now regression is part of multiple regression correlation, which is another part of the general linear model. And this one, compared to ANOVA, which more is about the between groups variance, this one's more about what they call the residuals, or the within groups variance in the ANOVA, or the error in the ANOVA. And this is their MRC and regression are more about want to check to see why there's so much residuals, why the residuals are there, and think they're a little bit more interesting than just error in ANOVA. So using the factors from earlier, we put them into aggression. But since it's aggression now, we can't call them factors anymore. These are now covariates. And so using the covariates, we put them in, we get this table, and using the B's under B's column under unstandardized coefficients, we get the following equation on the bottom, which is likelihood of depression equals the negative 1.22 times the stability of the home minus 0.08 self-report happiness plus 0.435 support group availability plus 1.25, which is our constant. So that is the regression equation that we get from this. Now, how we want to run some diagnostics to make sure everything's good, because ANOVA we ran and things were iffy. We want to double check this one too. So how we do is first run our T statistic. So the T column, as you can see there by itself, how we get that column is we take the B's and divide them by the standard error, which is the next column over, and we get the T statistic. And that gives us our significance. It helps us get significance. There's another equation in there, which off screen. And SPSS ran for you. And we look at the significance of all our covariates, and only home stability is significant. Now you're like, all right, we need to double check this and run some more diagnostics. So we ran collinearity statistics. You want to make sure that our data isn't collinear, aka each of the independent variables, the variances aren't from another independent variable. They're completely independent, which is an assumption we're going to get to. How we test that is for the collinearity statistics. Now, tolerance. Well, how that happens is we want the tolerance to be as close to 1 as possible. If it's close to 0, there's more variance from other independent variables. But if it's close to 1, that means the variance is within groups. It's not from the other variables. So that's all of them are 0.9, so that's good. Now, the variance inflation factor is just saying the same thing in a slightly different way. Now, the idea is the same thing to try to be as close to 1 as possible, but on the opposite side, it's greater than 1. It's always greater than 1. So we want to get as close to 1 as possible. And by doing so, since all of this is 1.07, 01, 09, that's really good, and that definitely checks off the assumption that the independent variables are independent of each other. Now we're going to move on, continue our diagnostics, and we'll come back to assumptions in a minute. This is an ANOVA, which we ran over. This is an omnibus test for all of regression. This is now the omnibus regression for depression. Hey! Now we look at this. We want to continue our diagnostics by running parameters. We check our parameters by look at degrees of freedom for regression, which is 3, and the total degrees of freedom, which is 29. Now this one we're doing that we get a number off screen and compare it with our 2.166. Now SPSS has already run that analysis for us, and we get a significance of 0.116. And since that's greater than 0.05, we again fail to reject the null. Now we move on to our assumptions. Now we have 3 assumptions in this slide. We can go back to them. And the first one is that there's no errors of commission. So we haven't left any data out. We haven't left it out. That's essentially what it says. Have we left anything out? We haven't. Now, the next one is the means residuals equals 0. So essentially take all those points on that scatter plot, and the mean of all of them is that line across. It's a good sign. Checks. That the residuals equals 0, or equals equals 0, excuse me. Now, next one is predictor, or the predicted values are uncorrelated with the residuals. And basically, by having that horizontal line across, that's a good sign and checks that off, that our assumption for the regression. Moving on, we have the depression or our Y value in the regression only requires a covariance. Now, the covariates you see on the left in this table are support group, pace self-report, and home stability, and that's the only ones entered there, and the variables just nothing removed. So that's essentially what checks out, that we only use the variables shown for depression. Now, residuals are random and or correlated is the next assumption. I do that by using a Durbin-Watson test, and you see the model summary table on the far right is Durbin-Watson is 2.006. Now, Durbin-Watson we want to be between 0 and 4 is normally how the test was run, and we want to be as close to 2 as possible, meaning there's no autoserial correlation. 2.006, we're good. Moving on is the relationship is rectilinear. Basically, that the relationship between the predicted values and our y is a line, good line, and since we have a good line right there, it's a good check on that one. And then we have homoscedasticity, which is back from our, which is just the variances, are roughly together. And for this one, we did a graph, and since the points are very well wrapped around the line, it passes that assumption. Now, finally, I promise, no more assumptions for regression, is that residuals are normally distributed. And since we have that nice curve, good, checks out, moving on. Now the results. Now that was a lot of information, went through very quickly, but the point of all that is this, the data results. And what we've got to from regression, since we actually got something, is that home stability, there is a significant difference between it and depression in children. That means there is something significant there. Now there is no significant difference for child depression and self-report happiness, or this child depression and support groups. Now, conversely, in ANOVA, this is why I run 2 different models, is there was no significant difference between any of the factors and depression in children. That is probably due to heteroscedasticity, or the failing of that assumption, but we'll get to that then. I want to thank you all for that, and I hope you have a great rest of your day.